Last but not least, this section is 2.6. It's about function notation and linear functions. We've been referring to them as linear equations. We can now refer to them as linear functions. When a function f is defined with an equation using x and y for the independent and dependent variables, we say y is a function of x. And this is used to emphasize the fact that y depends on x. So now instead of y, we can write f of x. And I read that out loud, f of x. F of x is just another name for y. Just like, you might have 15 million names for your cat. Hi, Bobby. It's good to see you. But it's still just a name for your cat. A function f can be written as the form f of x equals ax plus b, where a and b are real numbers, is a linear function, right? The value of a is our slope, right? And the value of b is our y-intercept. The domain of our linear functions goes from negative infinity to positive infinity unless otherwise specified. And that should make sense, right? If we've got a linear equation, let's graph a line, let's graph it in a fun color, green, right? That goes from negative infinity all the way over here to positive infinity. The only way our domain might be restricted was if our graph is a vertical line, but then it's not a function anyway, so completely ignore what I just said. So in order to write a linear equation in function notation, we need to solve for y and replace with f of x. So for problem 1, switching back to blue, if I have f of x minus 4y equals 9, we want to solve for y, as always. Negative 4y is negative 5x plus 9. Divide both sides by negative 4. Y equals 5 fourths x minus 9 fourths. So f of x equals 5 fourths x minus 9 fourths, right? This f of x notation tells us it's a function. It passes the vertical line test. Each x has a unique, each x has a unique y. It tells us a lot about what we're working with. For problem 2, I have negative 6x plus 2y is 8. I add 6x to both sides. 2y equals 6x plus 8. Y equals 3x plus 4. So f of x is 3x plus 4. So how could I evaluate a function? So let's let f of x equal 3x minus 5. We want to find the value of function f for each value of x. So what we're finding is the ordered pairs. So what is f of x? Well, f of x is 3x minus 5. My x is 2. So f of 2 is 3 times 2 minus 5. So f of 2 is 6 minus 5, which is 1. So that tells me the ordered pair. When x is 2, the output, the y, is 1. Let's try that again. X equals negative 1. F of negative 1 is 3 times negative 1 minus 5, which is negative 3 minus 5, which is negative 8. That tells me that when x is negative 1, my output, y, is negative